My name is Jari Augustin. I'm the CEO of Creanord, and I'm here with my colleague, PhD Klaus Dell, Senior System Engineer at Creanord. Hello. And as mentioned, this is our third Pulse Networks webinar with a special focus on 5G. So we will be doing two webinars about 5G. So the first one a few weeks ago focused on the business side of things. So basically, what are the market drivers, use cases, value propositions, etc. So after the previous webinar, I hope you had an idea why active service assurance is important in 5G. This webinar today will focus on technologies, network architectures, and technical side of things overall. And that will give you an idea how service assurance needs to be deployed to fulfill the promise of 5G. So the agenda for the next 25 minutes is the following. So I'll start the presentation by giving a short recap of the previous webinar. So just really quickly, and please know that you can get the previous presentation material on demand from our website. And then Klaus will go through how to reach the 5 nines availability, what are the key functionalities and capabilities to do that. And then it will be followed by the product demonstration. So let's start. So a short recap from the previous webinar. So the target audience for 5G cannot be consumers only. So someone else needs to generate the actual profits and revenues. And that market will be industry market and enterprises. And the quality expectations on those markets are totally different than today. So consumer markets like 4G hasn't really seemed to be that reliable. So the studies have shown that uptime on 4G networks is less than 99%. Consumer markets on a high level are based on the best effort. Consumers don't easily complain. However, industry market requires highest possible quality. Like 5G enterprise services are business critical. Quality, security, availability needs to be the best. And the network availability will be 5 nines, actually in certain use cases even 6 nines. So the consumer market is based on best effort, industry market is based on service level agreements. So this kind of a tectonic shift from 99% network availability to 5 nines is huge. It really is huge. So 99% means that the downtime is like nearly 90 hours per year. 5 nines availability means that the downtime is only 5.2 minutes per year. And then since certain use cases in 5G require 6 nines availability, the downtime can be only 32 seconds per year. And this shift requires that quality is not an afterthought. So we will build the network first and worry about the quality later. That just won't work. So 32-second downtime per year means that the quality is part of every network design plan from the day one. Multi-vendor environments, high number of devices, etc. So this also makes the outages really difficult to resolve. So it usually takes ages to even isolate these issues. And also the traffic growth continues to be exponential. So this is a challenge, is the transport infrastructure is shared to manage the costs. 3G, 4G, 5G, and many fixed services do share the same transport infrastructure. So obviously this is a challenge where the quality needs to be maximized. It's good to know that today in the transport networks, many operators are using like 2 to 4 quality service classes. So just one data point, you see that like the introduction of 5G, the number of quality service classes will be increased to 8. At least that is a requirement in many RFQs. So just to summarize, like 4G is our best effort networks, quality is moving to a totally wrong direction today. Thus, new ideas and tools will be needed to achieve the 5 nines promise. So how do we actually meet the 5 things? So every new site, every new customer location will be validated before the actual launch. So it is cheaper to fix these issues before the service launch versus troubleshoot complex network issues with live traffic. So do it right at the first time. That's important. Then 2, continuously measure the network, like every end-to-end connection, every segment, both quality service, application, quality as well. So we could say more the better. So more test traffic, more invisible issues actually can be detected. And then 3, when you have the reliable, granular, and accurate network data available, then you can use your management tools to ensure the high availability. 1, so predictivity is definitely the key. So service assurance data can provide warning signs, trend information about common issues. So when complemented with the artificial intelligence and machine learning tools, the service providers can easily operate their networks really proactively. And then 2, automation will be mandatory large deployments for sure. So with a large amount of reliable network data, the adaptive networks or these kind of self-healing networks can be implemented. And then last, number 4, so when you, the service providers, have time, kind of embrace the openness. So that was just a quick recap from previous webinar, but now I'll let Klaus to take over. So over to you, Klaus.
Thanks, Jari. Your services are working okay from day one. So the service validation tools are key here to get this job done and to validate the network before you actually run the live services and you verify that the network is meeting the requirements of the services before you put live traffic. So a good service activation suite will contain the Y1564 tests. These are for validating SLA criteria, the RFC 2544 to do more straightforward network performance testing, RFC 6349 to do TCP performance testing, and finally the IPERF 3 for more ad hoc type of performance testing. Definitely the most important of these tests is the Y1564 test, as it will validate your SLA criteria and it will do it for multiple flows simultaneously. It's particularly these multi-flow capabilities that makes it really the test protocol of choice for the 5G network. As you heard before, we are expecting to see operators using up to 8 service classes, so it's really important to be able to validate all of these service classes when you have traffic, a mixture of traffic from these different service classes. The reports that you obtain from these service activation tests can further be used as birth certificates. They are proving that the service will work as expected and that everything is okay in the network before you go live. And when you have good management tools that will keep a record of this, you have a repository of the results, and you also can benefit from it going live in troubleshooting situations, as it will provide you with some baseline references on how the network was performing initially. You can, of course, also fully automate these tests so that you have as part of your service provisioning workflow, so that you minimize the human intervention required to run these tests. In this illustration, I show how these different test protocols map into the 5G architecture. So here you deploy probes at the edge and at the core sites and cloud sites. In the 5G network, these probes will typically be virtual, but you can also deploy physical probes if that's more suitable for your use case. In addition, so you may also deploy small physical probes at selected locations in the network to act as end users and measure the performance end to end, taking into account also the radio interface to get a really true end-to-end view. For these end user simulators, the iPerf ad hoc tests are the most suitable to use. And again, between the edge and the base station, which is maybe the test that you will use the most, you would use the Y1564 typically each time you install a new base station. If you prefer, the RFC 2544 is suitable as well in this scenario. Again, between the edge and the cloud or core sites, you would typically run all of the tests in the suite to get a more complete picture of the performance. So you typically, when you install new core or edge sites, so of course this will be run at less frequency. I can also note here that if you don't have a suitable edge location to run the Y1564 test towards a new base station, you can of course also run this test from a core site all the way down to the base station. That's also a very valid scenario. So to recap of the service activation suite, the Y1564 test is really critical for 5G due to its capability to test the multiple service class flows. But if your workflows are already built around the RFC 2544, that can of course be used as well. The RFC 2544 test was actually originally designed more for really performance testing devices rather than networks, but it is definitely used a lot for network performance testing. It will just not provide that rigorous details compared to the Y1564, but provides a really good overall performance view nevertheless. The RFC 6349 and iPerf 3 complement these tests by providing more details on layer 4. So what's important to understand is that these Y1564 and RFC 2544 tests are based on UDP and are good for the basic network performance testing, but it doesn't really provide a true picture on how the TCP protocol will perform on your network. That's why you need these additional tests for that. And the issue with TCP is some shaping, policing misconfigurations in the network, or some other flaws in the network may actually affect the TCP performance quite severely, while UDP traffic is less affected or almost not affected by these issues. So that's why you need to complement it with the RFC 6349 tests or iPerf 3. Okay, so moving on to the active monitoring at high granularities, so that you get really a full visibility into how your network is performing once you have your services up and running. So the birth certificates we talked about, they are good at day one, and can be useful later on as well in troubleshooting situations. But as you are getting more and more traffic onto your live network, the active monitoring part is really critical here to ensure that you stay on the pulse of your network. As you know, in today's world, so the slow is the new down, so you cannot only look at packet losses or link outages, you really need to see a more detailed view of performance degradations and also monitor increases in delays and jitter, which can really significantly affect the user experience. And also, as you heard, for the business side, SLAs will be quite important in the 5G. So it's also important that you stay on top of the SLA status in real time. so that you can react to issues that have the most effect on the services if you look at it from the respect of the SLA definitions. Also, accuracy is a key element in the 5G network. In the 4G network, it was perhaps sufficient to measure delays in milliseconds or tenths of milliseconds, but the stringent requirements you have on the delays on the 5G network means that you really need to have measurements with an accuracy of on the microsecond level. And in this new world, so 1 minute or 5 minute averages simply are not sufficient any longer. So you need to be able to send test packets at high granularities every 100 milliseconds or even down to 10 milliseconds or 1 millisecond intervals to ensure that you are also catching potential microbursts in the network. And finally, the probe scalability is also key here. It was already important in the 4G network, but of course in the 5G network there will be a lot more devices to test and measure. So you do need to have probes in your network that can measure performance from thousands of base stations. Also taking into account that now in the 5G network you are actually measuring 8 different service classes rather than two or 4 in the 4G. So and of course the scalability is important as it ensures that your probe footprint is small in the network. You just need to install it in a few sites in order to cover the whole access network, and this just to ensure that you keep the cost to install and operate the solution down, and that you can quickly also deploy the solution. In this picture, we see how the active monitoring protocols fit into the 5G architecture. So TWAMP is used between the edge and base stations, and also potentially from the core sites to the base stations to capture the full path characteristics from the core to the base station. The net precision protocol you see between the edge and the core or cloud sites is a Creanord optimized version of TWAMP that we have designed, which is especially suited for these types of core network monitoring scenarios. And also when we are looking at the active monitoring, there's one new component, which is that you also need to go above the layer 3 and layer 4 that you normally do. You also need to focus on the user experience of the services. This device that you can put in the network to simulate an end user can run user experience monitoring measurements that will actually provide an estimate on how the end user is actually perceiving the performance of the service by measuring, providing a view on multiple levels on the service KPIs, both in terms of the physical signal strength by the mobile network, connect times to the services within the network, as well as internet service related KPIs. And related to this is also a similar the web application user experience monitoring, where you are doing a similar thing for web applications, which are very important also in the 5G scenario, where you are similarly testing on multiple levels how the web apps are actually performing over the mobile network. Okay, so to recap, the TWAMP and net precision protocols are the key measurement protocols to monitor the access and core networks respectively. TWAMP is perhaps more suited for the access network, particularly as the TWAMP reflection functionality is implemented in most devices. So meaning that you only need to install a probe at the central site to be able to measure performance towards the base stations. And when you are looking on top of this, you need a user experience monitoring tools to extend your view to layer 7 revenues from businesses. And that's why you need to also be able to measure how these businesses are experiencing the service, both from the user perspective as well as how their applications are running on top of the mobile network. Okay, so I move on to the reporting and analytics. In this earlier section, we focused on the probes and how they produce the active, accurate, and agnostic data by running measurements over any of the networking technologies, whether you have optical, Ethernet, and so forth installed. And once we have all this data, we also need that data to be actionable. And these reporting and analytics features will summarize, analyze, interpret, and forecast based on this data to turn it into concrete actions. And to illustrate a bit how this is done, I will highlight this with a few examples of what you can do. So the first we have the map view. So this really combines geographical data with the measurements and with the analytics that will show you where you are doing good and where you have issues in the network with respect to your performance targets. So that you can quickly focus on the areas where you need to fix something. So this is from a geographical perspective. You can also do it in the dashboard tool, where you can view the status according to different service groups, according to different criteria, such as you can look at certain geographical areas, you can look at important customers, or you can look at your leased line performance versus the own infrastructure, and so forth, with really customizable criteria on what types of categories that you want to monitor. And this helps you to focus on the most pressing issues in the network, as it will show a summarized state of the services based on whatever criteria you have defined. And then to also, as you are rolling out the 5G network, you also have the availability report, which will really give you a bird's view on how the entire network is performing in terms of moving towards the 5 nines targets. It will show you a general overview of how many of the services that are already at the 5 nines level, how many are at the 4 nines, 3 nines, and so forth. So it provides you kind of a status on where you are in terms of the whole network, and provides you then a confidence that you are moving in the right direction. As put in more actions in the network and utilize the tools, you'll see more and more services moving to the 5 nines level. Continuing with the root cause analysis. So of course you have a lot of data. The tools in the previous slide help you focus on where the issues are. Then you need to have a very flexible tool to examine the raw data and really dive deep and correlate different KPIs together and view different time scales and so forth, so that you get a good sense of and understanding where the root cause may be. So so when you combine this root cause tool with the drill down capabilities from this dashboard, so that you link them together and can quickly access the root cause analysis tool, it ensures that you can quickly find the right services to troubleshoot and find the root cause quickly. And last but definitely not least is the proactiveness. You in the 5G you really need, because the downtime is so precious, you need to really minimize it to a few minutes. You do need to move from a reactive mode to a proactive mode, and to do that you need machine learning AI capabilities that calculate trends in the network. It will compare deviations in the traffic from normal baseline behaviors based on the history of the traffic in the network, as well as can warn you of issues ahead of time before the performance degradation gets so bad that it's actually affecting the end user services. And finally, once you are at the state where your network is performing as you want, you will also want to convince your end customer that this is the case. And you can do this by offering a portal to the customer where you share performance measurements for his service, both in real time and also as regular monthly SLA reports. And the same portal can also provide a map view of the services, as well as then real-time views of the latest events that have happened to the services to ensure that your customer has a full view of what is going on with these services in the network. As always, automation is key. You want to integrate the data with other systems in the OSS stack. You might have an owner portal where you want to integrate these performance measurements and data and so on. So the open interfaces are really key. Kafka is particularly useful as a bus to transfer large amounts of performance data in real time to the other systems within the organization, and it scales very well to extremely big data scenarios. This Pulsar solution from Creanord actually will offer you all the tools that we went through and features to help you really get up to the Fun Nice level for your new 5G network. So I'll do a couple or a few highlights of this system in the form of a few demos. So I'll start up with a demo on how you validate SLAs for new services based on the Y1564 test. So here on the screen you can see our system. In the middle we have the probes where we have the Y1564 capabilities. Once you have run the tests, we have this history report, so I can go back and look at all the site verifications I have done so far. Actually, when I'm then verifying a new site, I can just pick an old one as a template. It has all the good definitions. I just alter the name of the test and the target of the test, and then usually I don't need to alter other parameters. But if you look here, for instance, in this case, I'm testing 4 different flows, but we have the capabilities to go up to 12 flows, so you can well above the number of service classes that you use in your network. Then for a particular flow, I can also go and look at the specific parameters, committed rates, birth sizes, service acceptance criteria for that flow. And then once everything is done, I just run it, and I can also schedule it, of course, to be run later. And once completed, I will get a PDF report with the results, very detailed report. So this is the birth certificates that we talked about earlier. First in the report, we see some basic parameters when it was run and what base station, what time. Look at the individual service flows. As you see here, as we are really talking about microsecond level results. And at the end of the report, I will have the performance verification report, perhaps the most important part, as it's then running all of my defined flows at the same time and measuring the same performance. So the reports before was for individual flows, and then here I have the results when running all of these service flows at the same time. Next, I'm going to show the active monitoring part for the services. In this demo, I will configure a new TWAMP target to be monitored. So I'm adding a base station, and I want to monitor that. In the middle, again, we see the probes where I can configure these TWAMP measurements. I will add a new target to an existing measurement, so just a new base station to be monitored. As you see here, the packet intervals, we can go down really to a 1 millisecond interval if you are running really high reliable and ultra low latency services. In the 4G network, packet interval would typically be 1 second, but for the 5G, you need to go really sub-second or maybe even down to 1 millisecond or 10 millisecond intervals. Looking at the KPIs, we have the normal delay and loss KPIs, but we can also measure the mean opinion score for voice services, and also quite useful is the ability to also see if there's some recoloring happening in the network, if DSCP values are changed, which can be quite useful in troubleshooting situations. Okay, so let's just add the new base station at Merida. Just basically need to add the IP address, and then I'll add it to the geographical map as well here. And finally, if I need to, I could also alter the DSCP value, but in this case I will use the best effort DSCP value. So I add the target. This was manual. Typically you have a lot of targets to add, so you can also have a file generated from the inventory system, add thousands of targets at one time, or you can of course fully automate it as well, so that they are provisioned from your inventory system. Okay, so let's go and see at my newly provisioned base station. I can search for it by name, so it's very quick to find, even if I have thousands of base stations. As you can see here, I already have results from the newly provisioned service, and I can go and examine the detailed values. Everything is looking good so far, and if I go and refresh the graph here, you can see that more and more data is flowing in. So I'm really staying at the real-time view of how my network is performing. I can also have the graph, of course, update automatically if I want to. Active. using our analytics, machine learning, and AI capabilities in the system. Here you see the overall map view. At the bottom there, you see the trend line view. We can here I could see if I have some traffic patterns, there are a lot more traffic. I can also go and look at my links. They will be colored according to whether they are meeting the criteria or not. If I look at this link, I actually see I have some baseline errors. This means they have cleared already, that's why it's green, but I did have some baseline errors, meaning that I was not necessarily crossing thresholds, but I was having some deviations from the normal traffic baselines that we see based on the history. Here I have the dashboard that I talked about. I had the last one customer there is have a factory automation slice with 16 services. I can see that 9 of those are not meeting service criteria right now. So I can go in and see a more detailed view of all of these services and how they have performed at an hour level, daily, weekly, monthly levels. And then based from this view, I can then further drill down to hourly charts, or in this case, I jump down to the raw data charts to do the root cause analysis and fix the services that are currently not working for this customer. That's really how you can very quickly drill down and fix the issues in real time as they occur. Then finally, a demo on how to build trust with your end customers, and I'll show you a demo of our portal. So basically, this portal is showing very similar views to the end customer as we saw earlier. I have a similar type of service view with the real-time status of the services. I can also drill down to the raw data from this view, so the end customer can also have a look at his services in real time. And there's also then the monthly SLA reports in the form of Excel files showing how the services has been performing. So if I unhide the details of that report, we'll see that it contains all of the KPIs that have been measured. And then the most important column is really the pass and fail column, which will then show which one of the services passed the SLA criteria and which ones failed. And then I can look at the more details on which KPIs did it fail. You can also see a real-time view of the events that have happened for my services. And I can also, in some cases, it can be useful to actually have the map view and see which of the links are currently performing well and which are not. So if I have some issues, I can go here quickly and check whether if it's the network that's causing the issues, or if my problems with my intranet is somewhere else, for instance. Okay, so that was really the last demo. Ends our presentation. And
so there are a few questions. These are for you, Klaus.
Okay.
So let's start with this. So how is the net precision microsecond measurement more useful in 5G compared to TWAP?
Well, the net precision has really been designed for the core network monitoring, and one of the key features there is that we can both see the two-way delays and the one-way delays with very high precision. So we are also running these between our probes, so you have also the accuracy of these measurements are really excellent. So which you need in the core, you need to have even more better accuracy than in the access network.
And I believe the scalability of net precision is also slightly higher than for TOAMP.
Yeah, yeah.
So which obviously is important in the core part of the network.
Yeah.
Another question also to you, again, how can Kafka be useful in big data machine learning scenarios?
Oh, Kafka is very useful in terms because particularly in big operators, they usually already have some machine learning systems in use, maybe analyzing logs, analyzing a lot of other data sources from the environment. And with the Kafka, it enables us to export our data to this same machine learning tools that are installed so that you can enrich the data also with network performance data. So that will it's particularly useful for these scenarios to really bring the data into all of the existing tools within the operator organization.
All right, thanks. And then another one for you. So what is the parameter measure for mobile user experience and web applications?
Okay, so we are really doing it on three levels for both of these tests. So we are measuring some basic physical characteristics, for instance, the mobile user experience with the signal strength and so forth. Then on the second level, so we are measuring sort of infrastructure services, connect times, how quickly do you connect to the network, how quickly do you get your DHCP addresses, DNS requests, and so forth. And then on the third level, we are really doing the kind of application level testing where we are testing the web performance on top of all of these other components.
And there seems to be one more. So could you please say a bit something about other integrations you have done?
Okay, so we have done actually in almost all of our customer cases, we will do some sort of integrations. It's been integrations with inventory systems, umbrella, fault management, and fault management systems and ticketing systems. We have used the Kafka for the performance management, umbrella performance management system integrations, for instance, and so forth. And we have a few examples where actually the operators have used our systems really as a closed loop automation platform, both exporting data from our system, but also using our, like we talked about, that these tests can be fully automated, so automating everything so that the human intervention to add new base stations is really not needed. So that when we add a new base station to the inventory system, it will be automatically provisioned in our system as well, and there will be automatic tests run towards that base station. Okay, I think that's it. So thanks everybody for attending this webinar. Please be sure to check our home pages and for more information. And I do want to also mention that we have a very exciting webinar about passive monitoring upcoming in a couple of weeks. So once you get on our homepage, you can at the same time register for that webinar as well. Okay, thanks again for attending. We will see you again in a couple of weeks, if not sooner. Thanks.